AB Calculus Notecard 17 product rule. This is the 17th lesson in the series inspired by Stacy McMullen, formerly the Dallas Independent School District, who developed this Notecard system of curriculum. Product rule. The product rule is one of our basic rules of differentiation, and it is the derivative of the product of two differentiable functions is the first derivative times the derivative of the second function plus the second function times the derivative of the first function, or this ddx of uv is uv prime plus vu prime. And now we're going to get to the problems that will apply this rule. 1. Find y prime if y equals 6x times sine x. And what I'm going to do is, in the habit of doing, labeling one function u and the other v. And so we're going to have y prime is going to be v u prime plus u v prime. Now what I do to make this easier in a more organized manner is to draw a box, as I'm doing the upper right, with 4 cells. Okay? So it doesn't need to be a really neat box. That one's not so neat. But what you do is you put here u prime up top. At the bottom, you put v prime. So u we've designated as 6x, and u prime is going to be 6. And for v, we have sine x, and v prime is going to be a derivative of sine x, which is cosine x. So y prime is going to be uv prime, so it's going to be 6x times cosine x plus v u prime, which is going to be 6 times sine x. And I guess we could factor out a 6 in this equation, but no need to do that. We're just going to call this a solution to our problem here and go on to problem number 2. Number 2, if g of x equals negative 2 cosine x times quantity 3x cubed minus 5x plus 7, find g prime of x. So very similar to problem number 1, except that we have more complicated functions. There's kind of busier functions. And so we're going to say g prime of x is equal to something we haven't figured out yet. I'm going to put the same thing we did for problem 1, make a little graphic organizing box, or in this case maybe a kind of a big box. So we have u, then u prime, v prime. So u is going to be negative 2 cosine x, and u prime is going to be the derivative of cosine is negative sine. So the derivative of negative 2 cosine x is going to be 2 sine x. And next, for this v function, we have 3x cubed minus 5x plus 7. And for v prime, we're going to have 9x squared minus 5. And now we can say g prime of x is going to be u v prime. Well, what I'm going to do is this. I'm going to say v u prime. So v is 3x cubed minus 5x plus 7 times u, which is 2, sine x, plus, well, we have uv prime, so we're going to say minus 2 cosine x times quantity 9x squared minus 5. And you can clean this up a little bit. You can take this 2 out front. So we have 2 times quantity 3x cubed minus 5x plus 7 sine x minus 2 I'll put 9x squared minus 5 times cosine x. So really, that's it. That's g prime of x. And that's as simple as we're going to make that. Okay, for 3, in the table below, r of x and t of x are differentiable functions. Find the equation for line tangent to q of x at x equals -3 if q of x is the product of r of x and t of x. So again, we're going to call this r of x u and t of x v. So what am I doing? Same thing, getting my box together, and we're going to say, okay, u prime, v prime. I find that these techniques help me keep organized, and therefore less likely to make mistakes. So if r of x is u, so that's -4, right? And then r prime of -3, r prime of -3 is going to be -2. And then v is going to be t of -3, or 2, and t prime of -3 is 3. So let's see, what do we have here? We need to have a point, right? You find the equation for a tangent line. So for a point, we're going to need an x-coordinate, which is -3, and we're going to need to have a y-coordinate. Well, we want r of x times t of x, so r of -3 is going to be r, no, q, we're going to find the tangent q, right? Let's do this. Okay, q of -3 is going to be r of -3 times t of -3. So q of okay, let's do it again. Q of -3 is equal to r of -3, which is -4 times t of -3, and t of -3 is 2. So we're going to equal -8. So our point is going to be -3, comma, -8. And those are going to be our x1, comma, y1. Okay, next, for the slope, we want to find q prime of -3. Well, that's going to be uv prime, which is going to be -4 times 3, plus v u prime, which is 2 times -2. which equals negative 12 minus 4, which equals negative 16. So our slope is going to be m sub t equals negative 16. So our tangent line is going to be y minus y1, and that's going to be minus negative 8 or plus 8 equals our slope m sub t, which is negative 16, times x minus negative 3, or x plus 3. So this is the equation of our tangent line. So really, in a problem like this, there was enough complexity and a lot of things going on that it was really important to keep track of things pretty well, which, in my way of thinking, the box really helped us to do. The next problem, and last one we're going to look at for this note card, is find the values of x for x between 0 and 2 pi, greater than 0 and less than 2 pi, where the tangent line to the graph of y equals sine x cosine x is horizontal. So let's go at it. So let's find the derivative. And to do that, what am I doing here? Similar to the way we did in problems 1, 2, and 3. We're going to have u prime, v prime, and then sine x we define as u, cosine x we define as v. So u is sine x, u prime is the derivative of sine x, which is cosine x, and then v is cosine x, and v prime is going to be negative sine x. So what we have here is y prime is equal to cosine x times cosine x, and then we have minus sine x sine x. So what that gives is y prime is equal to cosine squared x minus sine squared x. And if we set y prime equals 0, which is what we need to do to find where we have a horizontal tangent line, we have 0 equals cosine squared x minus sine squared x. And so for that, to solve for x, if we add sine squared x to both sides, we're going to see that sine squared x equals cosine squared x. Okay, and really what this looks like, I know what the answer is here, between 0 and 2 pi. Okay, if you have a 16-point unit circle, and here's a circle I'm drawing here, you have where sine x and cosine x equal each other at the coordinate pair negative 2 over 2, negative 2 over 2. So sine x and cosine x equal each other there. And also in quadrant 3, we have the coordinate pair. Let me go ahead and put our parentheses around here. We have our coordinate pair in quadrant 3. We have negative square root of 2 over 2 comma, negative square root of 2 over 2. So we know at pi over 4 and down here at, I think that's 5 pi over 4, we have answers. But what we have for sine squared x, we can have negative numbers as well work out for them to be equal. So here at 3 pi over 4, we have the coordinate pair negative square root of 2 over 2, comma square root of 2 over 2. And this point would also qualify, as would this one over here in quadrant 4, square root of 2 over 2, comma negative square root of 2 over 2. So each one of these values would qualify for, so we would say, find the values of x. So we would say x equals pi over 4, 3 pi over 4, 5 pi over 4, and in quadrant 4, 7 pi over 4. So those will be our answers to problem 4. Good luck. I hope this has been helpful, and thanks for viewing.